So, we discussed about a devices. Okay? Discussed about a devices, and here in this one, three things I've written, like five things totally. These three things are belongs to connecting devices. Okay, for connecting devices. So device required NIC, and we need a cable or some media. It is maybe wireless also, the same thing. So need a device to connect it and create a network. Now we are created a network. Now we want to communicate. Communicate. First thing is you need an address, right? You're sending a letter. You're sending a letter. So you will write to address and from address, right? So here, what address we are using is a logical addressing. So in general, what we are using is logic. Address means it is logical address, to address and from address, right? So what we are using is IP address. We are using for a logical address. There are different types of logical addresses are there, but what we are using is logical address only. Okay, sorry, we are using is IP address only. So it is IP addresses we are using for communication, and we are using twisted pair cable. Mainly UTP cables are using to connect it. We are using star topology. In physical topologies, we are using star topologies. And our network model, the way of we are communication, that model is TCP IP protocol suite model. Okay. So what we are using is important in that. So there is so many others out there. Okay. Again, we came to the IP address. So out of five, three are completed. This is the fourth one is IP address. IP address is a logical address. IP address is a logical address, right? And it is IP address is a uniquely identified device in the network. So in my network, I have 100 devices. Each device I am identifying it in the network through its IP address only. Is it belongs to my logical network or not? How can we understand by its IP address? These IP addresses we can assign, are given, are configured. Any word you can use. Best way is the IP addresses are assigned or configured. You can use assigned or configured by manually can assign it, or manually we can assign the IP address. Okay. Automatically we can assign IP address. Manually we can assign the IP address. Automatically means there is a DHCP server, separate DHCP server is there. This DHCP server is automatically assign IP address to the client devices. Okay. So these IP addresses can be changeable. You can change manually, you can change it. Automatically also you can change. I'm here in my office. I got an IP address from my office DHCP server. So when I go home, my home Wi-Fi router act like a DHCP server. From there, I am getting an IP address. Okay. So if I use my mobile hotspot connectivity, from my mobile phone hotspot service, I will get IP address to my laptop. Okay. So it meaning is wherever you are connected, so which network you are connected, in that network, in any form DHCP service is there, so you will get IP address from that DHCP automatically. Okay. Or otherwise you can configure manually also. IP addresses define logical network. So I have hundreds of computers. I want to logically divide this entire network, I want to divide them logically. I can also divide them logically using IP address configuration. For example, there is a specific department, HR department, must communicate each other and not to communicate other networks. So you can divide them logically also possible. Okay, means I will configure IP address in a different way of network like that. Every device must have an IP address to communicate in the network. Your device must have an IP address, whether you are using laptop or mobile phone or maybe a computer or maybe any smart TVs. So you want to connect in the network and communicate through network means, first of all, our device is required an IP address. To communicate other devices from my device to other device, first of all, my device required an IP address and I should know other device IP address. Right? You have a mobile, you want to call to someone. First of all, your mobile should have a phone number, right? You must have a SIM card, you must have the phone number inside. You're calling to someone. Means someone's phone number also you require. First of all, you should require your own number, then only you can call to another. It's like that. Without IP address, you can't communicate. So you must have an IP address to communicate, and you must know the IP address of your destination to communicate. These IP addresses, two versions. One is IPv4 version. Still we are using this IPv4 version in globally. And IPv6, another version, also using in some private networks and in some countries only. Some private networks means IP, for example, if you take Geo broadband, that is IPv6 communication. IPv6 IP address they use mainly. Okay. Certain countries, for example, Japan, Germany, small countries, there are using IPv6s, whole countrywide. Okay. So we have a different service providers, different companies we are using. So then IPv4 and IPv6, both we are using. Not only this, very big countries like US, okay, Australia, UK, those countries also using IPv4, countrywide public network. And in some private net, within that one also, some private networks, they use IPv6. Some are use both. Okay. This is an example of IPv4. So 192.168.10.22, just for example of IPv4. It's represented in decimal format, is like that. IPv6 is 32 bit size. It's a very big one. Okay. And as well as very small one also. This is also one IPv6. This is also IPv6. This is also IPv6. Different methods are there to write IPv6. Okay. So now we are not going to the methods and all right now. So we'll see at least IPv4 and IPv6, some differences and about IPv4. Okay. Just understand what is IP address. It's a logical address, uniquely identify network device in the network. We can change IP address. We can configure IP address manually. We can configure automatically also configure. What is use of DHCP server? Okay. Every device must have an IP address. All communications by IP address. Understand this part?
Yes, sir. Sir, I had a question about IP addresses.
Now tell me.
What if someone asks different types of IP addresses? Would it be dynamic or static, or IPv4 or IPv6?
Okay, good. The first one is static. Very good question. That is static. Because we are not went to that IPv4, IPv6, how it is look like. So we'll see then, we'll understand it. But static means you have a system, means your adapter is there, you're configured it, manually you are configuring, means you open the system NIC properties. Okay, so you go to run ncpa.cpl. So you have an adapter and you are configuring IP address manually. Like this you have to go. I will show you again once again after this completion. So this is, I can able to configure IP address manually. I can change the IP address according to my network. Okay. This type of IP address are static IP, means these IP addresses won't change automatically. You have to change it again. You have to change it. And for example, I'm here in office. As per my office network, I configured an IP address manually. Once I go home, different network. Again, as per that network, again I have to configure manually. So that type of IP address is static. Static means automatically IP address won't changes. This static way of configuration means manual configuration generally used in a servers, because servers IP address always constant, same IP always. We can't we don't move it. Okay. Dynamic means you have a DHCP server. You don't need to worry. So where is my DHCP server? Means your Wi-Fi router is also act like a DHCP server. Okay. So whenever you power on your system, in your adapter, nothing is configured. No IP address is configured inside. Okay. Actually, no IP address is configured. For example, mm, properties. See, nothing is configured. Just option is selected, obtain IP address automatically. Obtain DNS server address automatically. So I selected only this automatic option. Obtained IP address automatically. So what is this adapter will do it? Okay, what is this adapter will do it? So it will try to search where is this DHCP and get an IP address from DHCP server, and it got a IP address automatically from DHCP server. Okay, this adapter got IP address automatically from the DHCP server. So it is details. So I got IP address, subnet mask, default gateway, DHCP, DNS server address, and DHCP enabled now. Meaning is DHCP enable yes and DHCP server address. Meaning is this IP address configured automatically. Okay. And from this DHCP server, I got this IP address, the subnet mask, the default gateway, DNS server addresses. That is the meaning. Okay. So when you see a configuration, DHCP enable yes and DHCP server address means it is a dynamic IP, and this is the DHCP server which is given IP address to your device. Okay, understand difference between dynamic and static?
Uh,
Yes,
yes,
means yes.
actually, once a HR asked me about different types of IP addresses, and I told him IPv4 and IPv6, and then she told me that these are not the types of IP addresses.
Okay,
So that's why I was asking what to answer if someone asks me different types of IP addresses.
that is actually wrong question. Even I heard one time this question. Maybe we can say like this: public, static, dynamic, private IP addresses. There are several types. because it's not exactly type, means public IP address, private IP. That's one type. Dynamic and static, another type. IPv4, IPv6. Two versions, but two types. Okay. So direct way, you should not ask that question. But of course, when you say type means you can say public IP, private IP. Dynamic IP, static IP means static means manually configured. If you see the DHCP enabled no means this IP address is configured manually. DHCP enabled yes means IP address configured automatically. So it means dynamic IP address. This is static, that is dynamic. Okay, no means static, yes means dynamic. Okay. Another one is a private, public and private, static and dynamic. There's a classes also there, of course. Um, but we can see classes are not types of IP address. So types of IP address, yeah, IPv6 and IPv4 are versions IP address or IP address versions. You can tell that one also. That one. Okay.
Okay, sir. Thank you.
Good. Okay. So IP address, statical configuration, and automatic configuration. Automatic means DHCP enable yes, and you can also see the DHCP server. Public and private IP, I will explain after this completion. So what we are discussing is IP V4 version 4, okay, and IP V6. Two versions. IPv4 in a binary, if you write IPv4 address in the binary, it is 32-bit size. 32-bit. IPv6 is 128-bit. 128-bit. Total IP address means starting first IP to the last IP. The total IP addresses. So the formula is 2 to the power of 32. It means it's 4.3 billion IP addresses. 4.3 billion IP addresses. And an IPv6, 2 to the power of 128. Okay. So it is around 3.4 into 10 to the power of 38. It's not a 1 billion, it is billions of IP addresses. So exactly something like a decillion something name is there for that one. Okay. 10 to the power of 38 means some decillion, some name is there. It's not comes under billions also. Billion, trillion, like that it will goes. Okay. It's a very big IP address network in IPv6. Okay. So IPv4 has limited size, but IPv6 is just like an unlimited size type one. But really it is not unlimited, but practically unlimited. Means more and more number of devices we can connect it. Okay, in IPv6. Very big IP addresses. More number of IP address and very big IP address itself. Okay. So as I said, IPv4 in binary, it is 32-bit in size. 32-bit in size. So if you write like this, so I'm writing in a binary format just for our understanding. 0, 0, 0, 0. I think 1, 2, 3, 4, 5, 6, 7, 8. So I will change it. Right? This is 8 bits, right? 8 and 8, another 8, and this is another 8. That's it. Remaining is not required. Okay. So totally 32. So 4, 8, 12, 16, and this is another 8, 24. This is 32. So this is the first all 32 bit means if you write an entire binary, this is 32. And this entire 32 bit is divided into 4 parts. So I'm dividing this entire 32 bit into the 4 parts and separated by dot. Separated by a dot. See, 4 parts are there. This is part number 1, part number 2, part number 3, part number 4. Totally, I divided this entire 32 bit 4 parts. 1, 2, 3, 4 parts. Each part, how many zeros are there? How many bits are there? Zeros are ones. So how many bits are there? Each one having 8 bits. Each one having 8 bits. Each part having 8 bits. Each one having 8 bits. So 8 bits. So then we call it as a octet, 8 bits. That each one we call it as a octet. The first one we call it as a first octet. Second one we cannot call it as second octet. Third one we call it as a third octet. Fourth one we call it as a fourth octet. Okay. So each part of the IPv4 address, okay, we call it as an octet. Why it is octet? Because 8 bits. It contains 8 bits. Next. And what is the size? Again, 8 bits. 2 to the power of 8 means 256. Meaning is 0 to 255. 0 to 255. It means each octet size is between 0 to 255, not more or lesser. Not more or lesser. Okay. So lesser is no chance because 0 is the last one and 255. It means no octet is more than 255. Okay. So first octet is between 0 to 255. Second octet is 0 to 255. Third octet is between 0 to 255. Fourth octet is also 0 to 255. Some people, for easy purpose, for first octet, they put a W. Second octet is X. Third octet is Y. And fourth octet is, they call it as Z. Just for naming easy purpose only. But really it is first octet, second octet, third octet, fourth octet. Okay. Each octet size is 0 to 255 size. Okay. If you write the very first one, this one, I'm writing same one again. 0 in the normal decimal format. 0, 0, 0. Now only these mosquitoes are came. Okay. First octet, second octet, third octet, fourth octet. This is the first IP address, starting one. And you can start writing just like you're writing 1, 2, 3, 4 kind of stuff. You can start it like 0 dot 0 dot 0 dot 1, 0 dot 0 dot 0 dot 2 like this. So these are IP addresses. So your IPv4 address starting 0 and 1, 2 like this, it will keep on going. How much up to it will go? 0 dot 0 dot 0 dot 255. 255 is the last one. Think like this. 9 is the last number of single line series, right? After 9, it is become 0. Like you have 8 and then 9 and it is again 0, 1, 0. And you go up to like 11 and 19. After 19, it becomes 20. After 29, it becomes 30. After 99, it becomes 100. After 999, it becomes 1000. Okay. Similarly, here it is 255. After 255, it is become 0. It's just all numbering points. All right. Okay. It becomes 0. Okay. And 1 will come here. 1 will come. Okay. And it will continue. Again 0 dot 0 dot 1 dot 1, 1 dot 2, 1 dot 3, and it reaches 1 dot 255. Then again it is become 2 dot 0. 2 dots. Okay. It keep on going like this. And finally it reaches the very last one is 255, 255, 255, 255. Okay, so this is the very first IP address and this is the last one. Okay, so this is the first IP address. So this is the starting range and this is the last IP address of IPv6. The total, if you write everything, that is the size of your IP address, 3.4 billion IP addresses. Okay. So IPv4, 32-bit, 4.3 billion IP addresses. Actual number is this one. Okay, actual number is less than 4.3 billion. Represented in decimal format, and IPv6, IPv4 is look like this one. So dots and separations. Okay. And total IPv4 is divided into 4 parts, means entire this 32-bit, okay, binary is divided into 4 parts. So it means we got a 8-bit for each part. Each part is 8-bit. That we call it as a octet. What we are calling it as a octet. Each octet is separated by dot. Guys, always spell this one as a dot, not a point. 192 point, no. 192 dot, 168 dot, 1 dot, 34. Okay. So octet means 8 bits. So 2 to the power of 8 is equal to 256. Means if you write from 0, it is the 255 is the last one. So 0 to 255 is in the each octet. Okay. So each octet. So range is only within the octet is 0 to 255 only, not more than 255 in any octet. So the very first one we call it as the first octet, dot second octet, dot third octet, dot fourth octet. You can also write, we can also, for easy convention purpose, we can say first octet as a W, second octet as a X, third octet as a Y, and the fourth octet as a Z. Okay. So this is each octet range is 0 to 255. Second one is also 0 to 255. Third one is 0 to 255. Fourth one is also 0 to 255. This is the very first IP address. And then second, third, it keep on goes and we reach the last IP is like this. The total IPv4 range is 0.0.0.0 to 255.255.255. Okay. Total IPv4 range is 0.0.0.0 to 255.255.255. This entire range we are divided into 5 classes. Different purposes we divide these classes. And mainly IP addresses are logical addresses. See, to make it logical way of communicating, means logically we can able to divide a network. So it is a logical address. We are saying it is logical address. Purpose is to divide network logical way. Okay. But if I am not dividing this one, just I'm using from 0.0.0 to 255 to 255 directly. So there is no logical separation way is that happens. So in a one way, like for logical separation part, for logically we can define this is the network, this is a host, this is one network, this is a different network logically, this is one network, this is different network. To do that one, so we need a classification, first one. Second one is utilization. Each network, each class of network, so number of hosts will be different. Okay. For example, you take class C, you can maximum 254 devices we can connect it. In class A, 16 million devices we can connect it. In class B, 65,000 devices we can connect it. Okay. So that is the difference. Depends upon your network, depends upon your network size, logical network size. You can choose which class of IP addresses. So that's what it is. So for the point of dividing our entire network into different classes. So one is to define logical network, to make it a logical network to not to communicate other network. Second one is depends upon number of devices. You can choose better which is better network instead of randomly selected. Okay. To check which IP address of its class. So when you want to know which class of IP address it is, so check their first octet of IP address, you know it is which class of it. Okay. And of course, this classification is done based on the first octet of IP address only. Okay. So that's why when you see the first octet of IP address, then you can decide which class of IP address. So these are the 5 classifications. Class A 0 to 127, Class B 128 to 191, Class C 192 to 223, the Class D 224 to 239, Class E 242 to 55. Okay. The Class A 0 to 127, actual range is 0 to 127 only. But in certain test books, Google searches, it shows 0 to 126 or 1 to 127 or 1 to 126. There is a reason for why they are showing, but original range is Class A is 0 to 127, Class B is 128 to 191, Class C is 192 to 223, Class D is 224 to 239, and Class E is 242 to 55. Compulsory all classes and ranges. You must by heart it, guys. Okay? By hearting, so means read it twice, thrice, 5 times, 10 times till you got it in your mind. Okay? So any time you can able to tell the classes and their ranges. What are the IPv4 classes and ranges? Okay. So what are the ranges? The class A range is 0 to 127. Class B 128 to 191. Class C 192 to 223. Important one up to here. Class D 224 to 39. Class E 240 to 55. ఇక్కడ అంతే same. Okay. Understand ranges, classes and ranges.
Yes, sir.
Only one. Okay. So I will tell the reason. So why this not using, but we are left this IPv6 aside. Okay. Uh, yeah. We'll see the differences with some IPv6 kind of stuff. Then we'll see. Yeah, there is two, 3 points. So I will complete these points. Then we'll see the IPv6 also. Same time. Okay. So there is a reason why in a certain textbooks or in a Google, some people say it's 0 to 127 instead of that one 1 to 127 or 0 to 126 or 1 to 126. Let's see it is. First important point is anyway, you cannot use this 0 series. 0.0.0. These IP addresses you can't assign to any device. You want to assign that device. So see it is, you're trying to put a 0 dot. See, this is a invalid IP address. Invalid IP address. It won't accept that 0 series. Okay. Even I am going to my adapters. And CPA.cpl. I need some adapter to assign. Yeah, I use this adapter. IPv4 properties, obtained IP address automatically. Okay, I'm just put a 0 only. and dot. Immediately, 0 is not a valid entry. Please specify the value between 1 to 223. Okay. You can use any IP address between 1 to 223. Okay. As it said. Okay. We'll see that one also. Okay. But this 0.0.0 IP address used by certain services like a default routing, DHCP client, DHCP client uses this 0.0.0 as a source IP to find where is the DHCP server. Like it's a kind of reserved IP which we cannot configure to our systems. You can't assign to your laptop, desktop, mobile. You can't assign it. But it is used in certain services purpose. But we can't assign. We can't assign or configure below IP address to a or any device. So then this entire 0 series, 0 after anything, we can't able to configure. So these are reserved IP used by certain services like DHCP client services, default routing services, yellow all device like a yellow all, deny all, that type time we use this kind of IP address reserved for that. Okay, that's why it is in certain test works they will start with the 1 instead of 0 because we can't assign the 0. But it's valid only. It is used by certain service, but we can't configure. 127.0.0.1. This is the most interesting one and very important one. Guys, my PC having an IP address, your PC having some IP address, but we are all commonly having a local host or loopback IP address. It's a reserved. So every device it's local IP for itself kind of IP address is 127.0.0.1. You will try to assign that one also. 127 immediately. IP addresses starting with 127 are not valid because they are reserved for loopback address. They specify some other valid value between 1 to 223. Okay. So you can't assign this 127 series to any devices, but this 127.0.0.1 is a reserved IP used for loopback self-testing. Loopback means self-testing. Your system, its TCP IP services are there inside a system for network communication. So network related services working or not. So you can do using communication. You can try to go to command prompt, ping to 127.0.0.1. Meaning is you're self-testing, means you're testing yourself. So make sure that network related services are running or not, okay, in your system. That is one use of this 127.0.0.1. Another one is self-host accessing services. Self-host accessing services. What is meant by self-host accessing services? For example, in my laptop, I have a MySQL server in same laptop only. And I have a client in the same laptop. Server is there, server application, client application, both are in same laptop. From connecting from here to here, so I don't require any of physical IP also. Just I will use this local IP. 127.0.0.1. Using this one, I can easily connect it. But for that application, I want to connect from outside. I have to use this machine's actual IP, not this local IP. Hmm? కావాల్సినప్పుడు. Okay. So 127.0.0.1, it is a reserved loopback or local host address used for self-hosting, self-host service accessing, and self-testing purpose. So we cannot use these IP addresses. Okay. And also you can't use this class E. Class E. Class E is reserved for future purpose. So some people say research and development. Some people say it is future purpose. Anyway, we can't assign any IP address in this range to our devices. And class D. Class D is a multicast address. Class D is a multicast address. It is used by certain protocols like deploying applications, deploying operating system, routing protocols, dynamic routing protocols like RIP version 2, ASGRP, OSPF, okay, deployment protocols like bootp kind of stuff, TFTP protocols, okay. You use these multicast addresses to do it. So multicast addresses, class C addresses, that 0 series addresses, 127 series address, we can't assign to our devices. Okay. Of course, there is one more series is there that is separately I will tell, but right now can't assign it. Okay. So that's why this 0 and 127 is they won't show for configurations. Okay. But 0 to 127 is exactly your class A range. Guys, understand the classes and ranges kind of stuff?
Yes, sir.
Good. So I given a list of IP addresses here. So take the IP address and identify. So when you see an IP address, see their first octet 137, sorry, 134, 134. In this range, it means it is a class B IP address. 156.178.1.44. So you have to see always the first octet. 156. 156. Again, it is class B IP address. 10.2.3.191. 10. 10 means it's a class A IP address. 194.2.10.34. 194, right? 194. It means it is a class C IP address. 227.127.0.12. So 127 is in next octet, so no problem. It should not be in the first one. Okay. So 227. 227 is it's a class D IP address. Okay. So these are the how to identify which class of your IP address it is. Okay. Guys, understand how to identify the IP address, which class of IP address it is?
Yes, sir.
మనం ప్లేస్మెంట్ రోజు వీళ్ళు కొంచెం ప్రయారిటీ ఇద్దాము అని చెప్పారు.
Okay. So we'll go with the IPv6 now, and I will give you small points about IPv6. Then we will go back. Take a break. Okay. IPv6. Already I told IPv6 is 128 bit. 2 to the power of 128 is 3.4 into 10 to the power of 38. 2 to the power of, sorry, 10 to the power of 38. Okay. It's a billions of IP addresses. Okay. So after 34, you put a 37 zeros. After 34, you put a 37 zeros. That much big. That much big IP address it is. Okay. This is the point. Next is IP 128 bit, right? It's totally in a binary 128 bit. IPv6 represented in hexa format. Hexadecimal. These hexadecimals are like this. Normal in a 1, 2, 3, 4, and 9. After 9, there is no 10, directly A. then B, then C, then D, then E, then F. After F, it is 1 0, 1 1, 1 2, 1 3, 1 4, 1 F. After 1 F, again 2 0. It's like that. So this is how it is represented. It's totally 16 numbers from 0 to F. So this F we write in the binary, it is 4. So XR numbers actually represents in a 4 binary formats. Always it is a XR number means you have to write in the, if you are writing in the binary means it's always 4-bit number wise only. 4-bit wise only. Okay, like this only. So A means 1010. B means 1011. Okay, 9 means 1001. Okay, 4 means 01 like this. So this is always represented in 4-bit binary format. One hexa is equal to 4-bit binary format. So this 128 is divided by 4 means 32. 32 hexa numbers are there. 32 hexa numbers are there. These entire 32 hexa numbers divide into 8 blocks. Okay, this 32 hexa numbers divide into 8 blocks. 8 blocks. Each block is separated by colon. So each block contains 4 hexa numbers. Each block contains 4 hexa numbers. So we have 8 blocks. Okay. First block, colon, second block, colon, third block, colon, fourth block, colon, fifth block, colon, sixth block, colon. Each block contains 4 hexa numbers. Okay. So you can see 128, 2 to the power of 128 is 3.4 billion billions of IP addresses represented in hexa. See, this is the one example of a IPv6 address. So first block, second block, third block, fourth block, fifth block, sixth block, seventh, and eighth block. All are separated by colon. So one hexa means it is 4 bits. Okay. So totally 32 hexa numbers are there from here to here. Okay. Next. It contains 8 blocks. It contains 8 blocks. The blocks are separated by colon. Each block having 4 hexa numbers. Each block contains 4 hexa numbers. This is, I want a little change. Okay. Little bit change. Okay. It's 32 hexa numbers is divided into 8 blocks. This is correct. And 8 blocks are separated by colon. And one more point we have to do. Each block contains 4 hexa numbers. Hexa numbers. Okay. So that's the point here. Okay. Hexa numbers. So hexa numbers. 32 hexa. Hex. It's normal. Guys, in IPv4, we divided this entire address. We divided this entire range of addresses into classes. But in IPv6, we are not dividing anything. Okay. So entire IPv4 we divide into 5 classes. But in IPv6, the entire range is in billions. We cannot divide it like that. But we have a specified ranges for different types of communications. For public communication, global unicast range. This is the range. Okay, for public communication, global unicast. For private advisory communication, within the LAN communication, like LAN, CAN, MAN kind of communication, it is for your own private network communication. So private ranges are directly defined. Okay. For multicast communication, within the group communication. Multicast means within the group, same types of protocol, or broadcasting, instead of broadcasting with the same type of protocol enabled communication. So multicast range is given. Any cast. What is any cast? Means like in a IPv4 having a broadcast ID. This is the broadcast of any. But in here, it is any cast. Any cast means it's like a only IPv6 enabled devices. Link local. Link local means same segment wise communication. Actually, every device configured automatically with IPv6. See, this IP address not given by me or my DHCP server. It automatically generated IP address by the system itself. By this system only, this IP address is generated using this MAC address. Auto-generated IP address it is. Link local IP address, which we can able to communicate within our private. Okay. So these are the ranges are given. No classification, no class of IP addresses, like dividing entire IPv4 into classes. That is, we are not doing it. Is we are making IP address classification. Means we take some ranges, some range use for public communication, some range for private communication, some range for a multicast. Some range means these are the ranges. Okay, these are the dedicated ranges. Some ranges for link local. Okay, link local is self-generated IP addresses. Loopback or local host is colon 1. Okay, loopback or local host IP address in the IPv4 is 127.0.0.1. In a IPv6, it's just a colon 1. In IPv4, unknown, we have a 000.0.0.0. Okay, in IPv6, it's just a colon only, nothing more. Okay, so like unknown, here it is like colon. So these are the major differences between IPv4 and IPv6 kind of stuff. Mainly classifications, class A, class B, class C is not there here. And of course, there is some more points are there, like a IP address divided into network and host portions. What is meant by network and host portions? What is subnet? Okay, what is the subnet mask? What is subnetting? Okay, and how to assign an IP address. I'll just showed, but will see in the text format. Okay. IP address assignment and other few things already we discussed, but once again we'll see. What is IP address and what is the protocols and OSA model, network related troubleshooting. These are all we discuss tomorrow. Okay. For today, happy and prepare some, give some after time for what we discussed yesterday and today about networking related to it. Okay. That's it for today, guys. That is also people are
So
not responding. Okay.
are provided in the group, right?
Okay. Yeah. Partha, tell me again.
The notes are provided in the group, right?
Same link only. Same
Oh,
link only.
thank.
Okay. Same link only. So every day if I send it, you will miss the previous notes. That's why always same link.
Okay.
Okay.
Thank you, sir.
Thank you guys. Thank you. So this today
Thank you.
afternoon records, I will share it after some time or maybe evening. Okay. Night. Thank you.
We can we can leave,
Yeah,
right?
you can leave. You can leave. So I'm also stop. I forget to stop.